In this one, we have alphanumeric comparison. The word the joining, there is plus, there is one space here, to the word bag. So all three things are concatenated, plus, plus, okay. Less than the word the, and there is a space here, and the word bag is concatenated. Okay, on the right side, on the left side of the relational operator, we have this expression. On this side, we have this expression. So we can solve either of this, but let's start from the left side. So in the left side, there are two joins. So we have to do the leftmost join first, which is going to be this one. Okay, so we join to a space. So the result will be the and a space here, which is the new string or new alphanumeric constant coming out of these two. So the rest of the equation or the expression will be plus bag and the rest of it as it is. So now we have this to solve. So now from here, we have again another join to do, the space with the word bag, this one. So that results in the bag, where this space is coming from the space here. Okay, so this is joined. Then we have the rest of the equation or the expression less than the plus bag. So now we have this. Now let's solve the right side concatenation. So when you add these two, there are no spaces anywhere within brackets. So you get the bag without any spaces, unlike here. Here we got the bag because there was a space here coming from this space here. Okay, right. So now we have this expression, the bag less than the bag without a space. The bag with a space here less than the bag. So this is, you compare like this. You take the first two letters, it's the same letter, so you ignore that. You take the next two letters, H and H, same, ignore that. Third letter, E and E, ignore that. Fourth letter, space and capital B. Now, as you know, if you look at the ASCII table, space gets ASCII value 32 and B gets the value 66 ASCII value, 32 and 66. So B is higher value, 66 space. So basically what is being compared now is the fourth character here with the fourth character here, because the first three characters are same. So the fourth character here is a space, the fourth character here is a capital B. And when you compare alphanumerics, what you are comparing is the ASCII value. So ASCII value of space is 32, ASCII value of B is 64. So 32 less than 64 is true. Therefore, this expression is considered true. Okay, that's how this becomes true. Then let's go to L. Next one. L is run greater than runner. Here what happens is the R and R are compared, same letter. No, this needs to be compared and it's false because R and R are same, U and U are same, N and N are same, no more letters here, but this has some more letters. So this is a bigger area in that sense than this word. Therefore, when you say run is greater than runner, therefore it is false because this has more letters after the word N. So therefore this is bigger than this one. So when you say run is greater than runner, that is false. Okay, if you say run is less than runner, then it will be true. But since we are saying run is greater than runner, it becomes false. Okay, next one. 9, this is a numeric expression, no double quotes. So 9 is greater than 16. You know that, right? So 9, can 9 be greater than 16? No, because 9 is a smaller number. Then 10, 11, 12, 16 is a higher number. So if you state 9 is greater than 16, the statement is a false. Therefore, this is considered false. But the same thing, if we do it this way, 9 within quotes and 16 within double quotes. So this is alphanumeric comparison. In this case, how the comparison happens is, it takes the first letter 9 and the first letter 1 and only compares. So the ASCII value of 9 is a greater value than the ASCII value of 1. It doesn't take 1, 6 and compare it as 16 because this is alphanumeric. So the first comparison that is done is against 9 and the 1. So 9 and 1, 9 has a higher ASCII value, 1 has a lower ASCII value. You can refer to the ASCII table I provided in the previous video. So therefore 9 greater than 1, 6 alphanumeric is true, because the comparison is now happening between 9 and 1, not between 9 and 16 like it does in a numeric. Okay, so that's the main difference between alphanumeric and numeric. Okay, so this is true. Therefore, why is it true? Because it's comparing the first letter of this with the first letter of this, not the not the combination of this. Okay, so 9 is greater than 1. Actually, it's comparing the ASCII value of 9 and ASCII value of 1, and we know ASCII value of 9 is higher value than ASCII value of 1. Therefore, this is considered true. So if you notice, if you compare it as numeric, it becomes false because 9 is not greater than 16, whereas if you compare it as alphanumeric, it is true because only the first characters are compared. If the first character is same only, it will go to the second characters of the two string. Actually, there is no second character here. Okay, so just remember that. Then here, let's look at the expression. Now here we are saying 30, it looks like 35 plus 10, 250 minus, no, it is not, because this is alphanumeric constants. So actually what we have here is 35 plus 10, and here we have 250 minus 10. These are strings, alphanumerics. So when they are alphanumeric, how does the comparison happen? It takes the first character of this, compares with the first character of this. So the ASCII value of 3 is more than the ASCII value of 2. Therefore, this string is greater than this, is true. Okay, it doesn't go to solve anything like it would happen in a numeric. So let's see that also. Here, this is a numeric of that same thing, done in a numeric way. In alphanumeric comparison, this was true because 3 was greater than 2. But as numeric, let's see. So in numeric, first we have to solve this. 35 plus 10 we have to do first and get the result of that, which is 45. Then we have 45 greater than 255, 250 minus 10. Then we have to solve this one, which is 250 minus 10, which is 240. So now we are having an expression which says 45 is greater than 240. That is not true. 45 is a smaller number. It can't be more than 240. No? So therefore, this is false. Okay. Whereas when you compared it as alphanumeric, it was true because it just compared only the 3 and 2, not the rest of it. But when you compare it as an alphanumeric, the expressions are evaluated and final results are taken and only compared, and therefore 45 greater than 240 is false. 45 is a smaller number, so you can't say 45 is greater. So this is false. That is P. Then the next set, the same set. I have now put all of them in one screen showing I to P. 3 plus 2 less than is false. So likewise, we solved all this. So each of the results I am showing in one screen for you to compare it and see. Okay. So now let's go to the variable ones. Now here we have variables, num1, num2, word1 and word2 are the 4 variables. Their contents are num1 contains 75, num2 contains 40, word1 contains the word less, word2 contains the word greater. So now first question is num1 greater than 70. So when you say num1, there is no double quotes here. So we are referring to a variable, this variable. So num1 is 75. So let's solve that. Num1 is actually 75. Right? So now we have greater than 70. This is part of the expression. So now what we are actually comparing when you say num1 greater than 70 is 75 greater than 70 because num1 is 75. So 75 greater than 70 is true. So this expression, comparison or condition, num1 greater than 70 is true if num1 is 75 in this case. If the num1 had a lower value like 40 or 30 or some smaller value than 70, then this will become false. But in this case, for this situation where num1 contains 75, this condition is true. This is how it's evaluated. Okay. So let's